lesson is on the cosine rule. So we're still working with these triangles. I'll do a better one of those. With these triangles where it's A, B, C, and that will be little c, that will be little a, and that will be little b. Like, that's in general form. The reality is that we don't really see it like, the questions, we don't really see it in that form, but the formulas are set out in that form, okay? So we're going to learn to use the cosine rule with non-right angle trigonometric problems, and here are two versions of it. Now, from the diagram, you can clearly see that C is a side length. So this one would be for a side length. And then big C, you can clearly see is an angle. So this one would be for an angle. So just keep that in mind. But let's have a look at what it looks like in the formula sheet. So it's under the same thing as our two triangles, the sine rule, area of a triangle rule, and here we have the cosine rule, and you actually get both versions of it. You get the length one and you get the angle one, and you don't need to rearrange at all. So that's really, really good. Okay, let's have a look. All right, so here in this example we need to find the unknown side. So here, now one thing to note is that see, this angle is opposite that side length. So that means we can just pop it in, because see how it's C and C in our formula? So let's pop it in. So it's going to be x squared, because that's what we need to find, equals a squared plus b squared. It doesn't matter which one we use of these two. It really doesn't. So let's go x squared, 8 squared plus 4 squared minus 2 times 8 times 4. See how it's AB, AB, okay? And then we're going to go times cos of 120. Now what I want to do, because I want an exact value, I know that I'm going to have to square root. So I'm just going to go x equals square root of everything of that inside. Okay, that's the way I would work it out. And that way our calculator will give us a pretty good approximation of what it is. So I'm just going to type that in myself, and hopefully you're doing the same thing. I'm nearly there. Make sure you're in degrees, and I get a side length of approximately 10.58300524. So I don't like that answer. I'm just going to put it to 2 decimal places, so 58. And yeah, we should put a side length. Let's put centimetres here. So this will be centimetres to 2 decimal places. Okay? So that's how we use the cosine rule. So essentially we just substitute it in. Now, one of the things to note about the cosine rule in all instances is that cosine rule needs all 3 sides to be in play and 1 angle. Okay? So all 3 sides and 1 angle. So cosine rule is all 3 sides and 1 angle. Sine rule is different, and the area of a triangle is different. Make sure you know those ones as well. Okay? So this is the cosine rule as well. So playing on what we did, all 3 sides are in play, and we need to find an angle. So we use the cosine rule. Okay? So, but this time, because we're finding an angle, I'm going to use this version of it. So let's just sub it in, and remember that is opposite to that, which means that this equals little c. So this will be this little c here, because see how it's opposite to big C? All right, so it's just something to be aware of, because everything else will just, like, it doesn't matter what order you have. If you've got any questions on that, please ask. So I'm just going to rub that out. Let's go straight to it. Cos theta, because we don't know what it is, a squared, I'm just going to make 6a squared, so 6 plus 5 squared minus 8 squared, and then we've got 2 times 6 times 5. Now I'm going to put that in my calculator. So I've got 6 squared plus, what was it, 5 squared minus 8 squared over 2 times 6 times 5. And I get minus 1 over 20. So cos theta equals that. Therefore, theta equals inverse cos of negative 1 over 20. I'm just going to pop that in my calculator. So I'm going to go inverse cos of the answer that I've just got. And I get like approximately 92.86598,398. So that is approximately 92.87 degrees, and that's to 2 decimal places also. All right, so that's how we use the cosine rule in 2 different ways. Hopefully that makes sense. Peace out.